Good morning, students. Today we are going to discuss the topic theory of interference, and it is chapter 10, wave optics. Now, last class we discussed a little bit about interference. Interference is nothing but the interfering of two waves of different amplitude with constant phase difference or with zero phase difference. Now, in this figure, we have made the coherent source from a single source. S1 and S2 are two coherent sources separated by a small distance d. Now the waves from S1 and S2 are represented by Y1 and Y2 superimpose at P, and as a result interference will occur. Now where the two waves superimpose, that is the point P, is on the screen, which is at a distance capital D from the slits. Now S1 and S2 are coherent source, so already we have defined constant phase difference or zero phase difference. Now in class 11 there is a chapter wave, so already you know how we can represent a wave mathematically. So if you want to represent waves from S1 and S2 mathematically, then we have to use this equation. The wave that comes from S1 we have defined as your Y1, that is your A sine omega t, and the wave that comes from S2, that is your Y2, that is your B sine omega t plus phi. These two sources, S1 and S2, are coherent sources. Coherent sources are sources which have a constant phase difference or zero phase difference. So here the phase difference is phi between the two waves. Now basically Y1 and Y2 represent the displacement of the particle suspended in air when the disturbance from S1 and S2 strikes individually. Now what will happen? These two waves superimpose at P, and as a result the particle which is inside at P suffered resultant displacement, and that resultant displacement is nothing but is your y equal to y1 plus y2. So y1 A sine omega t, y2 B sine omega t plus phi. So A sine omega t, B sine of omega t plus phi can be expanded, B sine omega t cos phi plus B cos omega t sin phi. That is your sine of A plus B formula we have used. Now we have taken the sine omega t common, so it comes within bracket small a plus B cos phi within bracket closed sine omega t and B sin phi cos omega t. Now number 4, we have replaced A plus B cos phi as your R cos theta, and B sin phi is your R sin theta. So if you substitute this one in equation number 3, then y equal to R cos theta sin omega t plus R sin theta cos omega t. So if you take R common, then cos theta sin omega t plus sin theta cos omega t. So R sin of omega t plus theta. So that is the formula of sin of A plus B. So the resultant displacement can be defined by this equation, y equal to R sin omega t plus theta, and R is the amplitude or the maximum displacement, you can say. Now here number 5 equation, what we have done, we have considered R cos theta is your A plus B cos phi, R sin theta equal to B sin phi. So what we have done, we have square and add it. So if we square it, R square cos square theta plus R square sin square theta, then A plus B cos phi already we have defined whole square plus B square sin square phi. So R square common, cos square theta plus sin square theta, and here is your A square plus B square cos square phi plus 2AB cos phi plus B square sin square phi. So R square sin square theta plus cos square theta equal to 1, A square plus 2AB cos phi plus B square within bracket sin square phi plus cos square phi, that is your B square. So A square plus 2AB cos phi plus B square, or R equal to root over A square plus 2AB cos phi plus B square. Now R is the amplitude of the resultant wave, you can say, and y1 and y2 is nothing but the displacement. So y is the resultant displacement caused by the superposition of y1 and y2. Now intensity formula already we know, intensity proportional to the square of the amplitude. So if R is the amplitude of the resultant wave, then resultant intensity can be defined as your I proportional to R square. So I equal to K R square. K is your constant of proportionality, so you can write Now in place of r square we have substitute a square plus 2ab cos phi plus b square. So if we expand, then k square, just a simplification, plus 2 a root k b root k cos phi. Root k is a k itself, so it's a simple, only the arrangement is there, kb square. Now ka square is nothing but the intensity of the wave caused by the displacement y1, and I2 is equal to kb square, that is the intensity of the wave caused by the displacement y2. That is your, in this formula, I1 equal to Ka square, I2 equal to Kb square, if you consider individual source. Now we have simplified this one, so it comes out to be your, if you take a root over, then a root k b root k, so a root k b root k you can replace by root over I1 root over I2 cos phi, and plus 2 or plus I2. So this is the resultant expression for the intensity of the wave caused by the superposition of the two waves that comes from S1 and S2. So I equal to I1 plus 2 root over I1 root over I2 cos phi plus I2. Now constructive interference, that is the intensity at point P, will be maximum, and under this case cos phi equal to 1, maximum value of I is your cos phi equal to 1, it means phi equal to 0. So phase difference is 0, you can consider. So the diagram little bit is like this. For constructive interference, this is the condition for phi equal to 0. Both waves are in same phase. Okay. So cos phi equal to 1. So in general value, phi equal to 0, 2 pi, 4 pi. So if you generalize 2 n pi, n equal to 0, 1, 2 like that. And I max is your I1 plus 2 root I2 root I1 root I2 plus I2. So if you take square, you can make I max equal to root over I1 whole square plus 2 root over I1 root over I2 plus root over I2 whole square. So you can say that I equal to root over I1 plus root over I2 whole square. This is the maximum intensity, and that is nothing but the condition for constructive interference. And the constructive interference, the diagram is like this. The two waves that comes from S1 and S2 are of same phase, that is phi equal to 0. Now another that is your destructive interference, that is your I equal to I minimum. So under the I equal to I minimum, when cos phi equal to -1. So cos phi -1 is your 2n minus 1 pi, n equal to 1, 2 like that. So if you consider n equal to 1, then phi equal to pi. So under the destructive interference, a phase difference of pi occur, which is defined as by the diagram or the waves that comes from two different sources, S1 and S2. The downward wave from S2, the upward wave is from S1. So they have a phase difference pi. That is your destructive interference, and that is intensity is minimum. So if you substitute cos phi equal to -1 in this formula, it comes out to be your I equal to root over I1 whole square plus minus root 2 root over I1 root over I2 plus root over I2 whole square. So ultimately we will get root over I1 minus root over I2 whole square. So if you take the ratio I max by I minimum, I max already we have defined root over I1 plus root over I2 whole square, and I minimum root over I1 minus root over I2 whole square. So under that case you can substitute from here. If you take root over I1, it comes out to be your a root k and b root k, a root k, b root k. So root k goes off, so a plus b by a minus b. A and b are the amplitude of the individual wave that comes from S1 and S2. Now the phase difference, that is phi. Phi is the phase difference between the two waves, is not it? Phase is your omega t and omega t plus phi. So phase difference is your phi. So phi is the phase difference. So phase difference for constructive is your 2n pi, and phase difference for destructive is your 2n minus 1 pi. So you can define one more expression, that is your path difference. Path difference is nothing but the length of the path that travels by the wave when it comes from S1 to P and S2 to P. So S2P is longer than S1P, so S2P minus S1P gives you the path difference. So we are going to use this formula, phase difference equal to 2 pi by lambda into path difference. So for constructive interference, phase difference is your, as per here, 2n pi. So 2n pi and 2 pi by lambda, path difference is your S2p minus S1p, as it is from the figure, S2p minus S1p. So if you want to find the path difference for constructive interference, it is your S2p minus S1p, 2 pi goes off, that is your n lambda. And for destructive interference, phase difference as we have defined here, that is your 2n minus 1 pi. So n equal to 1, 2 like that. So 2n minus 1 pi, 2 pi by lambda, S2p minus S1p. So S2p minus S1p is your pi goes off, 2n minus 1 lambda by 2. So this is your expression, and these expressions are important for the numerical. So please go through and try to find out your doubts. And these expressions are simple once you understand. So please go through and find out your doubts and make the things clear. So this is all about. Thank you.